Good morning, dear students. My name is Ferhan Mazher, and today is 4th of May 2021. And right now we are studying the subject of physics. This is O-levels physics, physics 5054. Today we have set our hearts to solve May-June 2019 2-2 paper. This is a theory paper, and this belongs from the zone 2. In this video, in this session, we are going to solve the section B. Only the section A of this paper I have already solved and uploaded in the YouTube. You can find it in my YouTube channel. So let's start today's paper. Let's go to the paper, and here we go. Okay. Answer, this is a section B. This is May-June 2019 2-2 paper. And you can see that answer two questions from this section, answer in the space provided. Question number 9, figure 9.1 shows a map of the route taken by a car as it travels from the town A to town B. So here we have a town A, here we have the town B. So the north is in the upward direction and the east is in this way. So we have to each square here, this approximately 1 centimeter represents 5 kilometers. So if you look at here carefully, try to understand this thing. Just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are 10 squares along the x-axis, so which means 50 kilometer. And on the y-axis, it is 1, 2, and 3. So which means 15 kilometers. So on the towards the east, it is 50 kilometers, and towards north, it is 15 kilometers. So it makes a right angle triangle. And then you can find out the distance displacement, the direct displacement from A to B. You can find out by using the Pythagoras, because this will be a right angle triangle. And its two sides will be of 50 kilometer and one side will be of 15 kilometer. By applying the Pythagoras theorem, I can find out the displacement between A and B. So let's check what's the question. He says, the journey involves the distance and the displacement. Using the scale on the figure 9.1, determine this displacement in traveling from A to B. So from traveling from A to B, I told you the trick that I will use this length, that's 50 kilometers, this length, that's 15 kilometers, they make 90-degree angle. So the direct distance or displacement from A to B, I can find out by applying the Pythagoras theorem. And he has asked you two questions. He wants you to find out the size of the displacement, and he also wants you to find out the direction of the displacement. I've done this on a paper. Let me show you how I have done. So here we go. Okay. So this is that diagram. Basically, I have drawn here. This side is 50 kilometers. This side is 15 kilometers. And I want the direct length from A to B. That's the displacement, the size of the displacement. And by applying because this is a right angle triangle, you can apply the Pythagoras theorem and you can find out the AB length. So AB length will be under root 50 square plus 15 square. And that will be 2500 plus 225, 2725, and the answer will be 52.20 kilometers. So the distance between the A and B, the displacement, direct distance from A to B, the length of AB, or the displacement of A to B is 52.20 kilometers. Then he asked us to find out the direction. The direction, because here the north is given, so from the north I can tell the direction. And from the north at A, clockwise, come to the AB line. I can tell that angle, but first of all, I will find this angle phi, which is inside the triangle. So I will use the tan phi equals to 15 by perpendicular by base. So phi will be equals to tan inverse 15 by 50. Just do this calculation. So phi value will be 19.70. And the theta you can find out, theta is 90 minus phi. So it will be 73, 90 minus 16.7. It will be 73.3 degrees. So the direction of the AB is north 73.3 degree east. North 73.3 degree east. Hopefully you have understood this. That was the first part. And let me check the marking scheme. The marking scheme. Question number 9 showing up on your screen. You can see the distance traveled before. Right, part. 51 to 53 kilometer will be the answer, and the direction will be from 72 to 74, and north 72 to 73, 74 degree east. This is the way to write. From north, you go this much angle towards east. So that's the right direction. The marking scheme is showing up. I hope that you have understood. I hope that you have understood the question. Okay, so let's move to the next part. The next part coming up on your screen, question number 9 we are doing. He says, state how, the question is state how the distance differs from the displacement. You see the distance is a scalar quantity, whereas the displacement is a vector quantity. Distance only has magnitude, whereas the displacement has the magnitude as well as the direction. So that's the basic difference between them. You can write this answer. And the next, let me check what answer I have written. It's very simple question. Okay, so okay, so here we have question number 9. Okay, so distance is a scalar quantity, whereas displacement is a vector quantity. Distance is a scalar quantity, whereas displacement is a vector quantity. Hopefully you have understood this. Let's move to the next part. We will check the marking scheme later. In some parts of the journey, the car is traveling at a constant speed, but is also accelerating. So explain how this is possible. This is only possible for anybody to be moving with a constant speed, but still having acceleration. That happens whenever a body is moving in a circular track, or whenever a body is taking a turn, because the body, when takes turn, moves in a circular path. Whenever you move in a circular path, your speed might be constant, but because your direction of motion is continuously changing when you move in a circular track, that's why your velocity is changing. That's why the body has acceleration. So it is possible, yes, it is possible that the body might be moving with a constant speed, but still it has acceleration. This happens whenever a body is moving with a constant speed in a circular track. Due to the change in the direction of the velocity, there is acceleration in the body. So it's a 2-mark question. Let me show you what the answer I have written, and then we will check the marking scheme. So, okay. If car is traveling in a circular track or turn, or a turn, its speed might be constant. It still will have acceleration because direction of velocity is changing when it moves in circle or a turn. Due to change in direction of velocity, car is accelerating. So car is basically accelerating. The reason is because it is moving in a circular path, and when you are moving in a circular path, your direction of motion changes, the direction of velocity is changing. So due to the change in the direction, there is acceleration. So let's check the marking scheme for these 2 parts. We have done 2 parts. Let's check the marking scheme first, then we will go to the. So question number 9A, second part, distance has no direction or distance is a scalar. Question number 9A, third part, changes direction or goes round a corner. Velocity changes or velocity depends on direction or acceleration. Force is towards the center of the circle. Centripetal force, I think the answer which we have written is good. So let's move to the Next question. Next question coming up on your screen, question number 9, B part. He says, here he says, at town B, the car makes an emergency stop. The total stopping distance of the car is thinking distance added to the braking distance. Describe what is meant by the thinking distance. You see, whenever a driver sees an obstacle in the path, and then there is some reaction time of the driver. And during that reaction time, his feet go to the brake pedal. So during that reaction time, the car will travel some distance. So when he see an obstacle and his feet go to the brake pedal, that is his reaction, and the time taken during that process, that is called the reaction time of the driver. And during the reaction time, the car covers some distance. Obviously, the car is moving at certain speed, so the car will cover some distance. So during the reaction time, the distance covered will be known as the thinking distance, or you can also say it like this, that the distance traveled when the car is moving and the driver sees an obstacle and his feet go to the brake pedal. So during that process, watching an obstacle and putting the feet on the pedal, during that, the distance covered by the car, that is known as the thinking distance, or the distance covered in the reaction time of the driver. That is thinking distance. Okay, so let me check the other two parts also, and then we will see the second part also, and then we will check its marking scheme and my written answer. The brakes on the car work badly. This increases the braking distance. State two other factors that increase the braking distance. The braking distance can be increased if the car is moving at a higher speed. If the car is moving at a higher speed, the braking distance will be larger. If the tires are not new, they are worn out, and then the braking distance will be larger. If the road is wet, the braking distance will be larger. And if the car is loaded, I mean it's heavy, its mass is larger, so then even then the braking distance will become larger. So you see, there are many factors. You only have to write two. Let me show you what I have written. So here we go. Let me increase the size. So the distance traveled by the car during the reaction time of driver when he sees an obstacle and his feet goes to the brake pedal. So the distance traveled during that, that is known as the thinking distance. And the two reasons we have to mention, there are many reasons, you just have to mention two. For example, I have written here worn out tires and high speed of the car. They make the braking distance larger. So that's it. So let's check the marking scheme. What the marking scheme has to say. Distance traveled before brakes applied after seeing emergency. So that is B, first part, thinking distance. B, second part is poor tire surface, poor road conditions, for example, rain or ice, high speed of car or good aerodynamic car shape or tailwind, large mass, weight of car, driver applies less force to pedal, less braking force. So these are the some reasons. You only have to mention two there. Hopefully you have understood this. Let's move to the next part. Okay, so the next part is the mass. The mass of the car and the driver is 1200 kg. Just before the brakes are applied, the speed of the car is 30 meters per second. Calculate the kinetic energy of the car and driver just before the brakes are applied. So the formula for the kinetic energy is 1/2 mv square. Formula for the kinetic energy is 1/2 mv square. The mass is given, the V is given, just do the calculation. It's a 3-mark numerical. And let me show you, I have done this numerical, 3 marks numerical. Very easy. Okay. So on your screen, you can see question number 9C, first part, kinetic energy is equal to 1/2 mv square. equals to 1 by 2 into 1200 into 30 square. So that will be, you do this in the, put this in the calculator, it will be 54 and 0.0000 joules. Okay. So 540,000 joules. And the next question, the next numerical is, we will check the marking scheme later. Let's first go to the next part. The next part is the braking force that stops the car is 1800 Newton. Calculate the deceleration of the car. Now you know the braking force and you know the mass of the car. So by using the Newton's second law, F is equal to ma. F is equal to ma. So by using the Newton's second law of motion, F is equal to ma, the force is given, the mass we know, we can find out the value of the acceleration. The value of the A will be equal to F divided by M. I've done this on a paper. Let me show you my answer and then we'll check them. Okay, F is equals to ma, Newton's second law of motion, 1800 equals to 1200 into A. A will be equals to 1800 divided by 1200. And the final answer will be 1.5 meter per second square. 1.5 meter per second square will be the answer. Okay, so the next question coming up on your screen, and he says, explain why the temperature of the brakes increases during braking. The temperature of the brakes, because you see the brake pads, they rub with the tires. So what happens? The brake pads, they rub with the brake drum. So what happens? There's friction between them. So when they're rubbing against each other, there's friction between them, and we overcome that friction. And the car tries to overcome that friction. And when you overcome the friction, your energy will be converted into thermal energy or heat energy. So that's why the temperature of the brakes will apply. So when the brake pads, they will rub against the brake drum, you see there will be friction between both the surfaces, but still they try to move. And when you try to overcome that friction, what happens? The energy will be converted into the thermal energy, heat energy. That's why the temperature of the brakes will rise. Let me show you. So this question number 9 is approximately done. Let me check the marking. Let me check my written answer. And then we will see during brakes, when energy used to overcome friction, energy is converted into heat. Due to this, temperature increases. So I have not written here that the friction between the brake pads and the brake drum. You can write whenever you name friction, use the word friction, you have to mention the surfaces between which the friction you are talking about. Okay, so let's check the marking scheme, what the marking scheme has to say. You see, I can go to the marking scheme, and you can see the marking scheme says 540,000 joules. That answer is right. And then 1.5 meter per second square. Question number 9C, second part, that answer is also right. And the last one is friction produces thermal energy or kinetic energy changes to heat or work done against the friction. So our answer is right. So this was question number 9. We are done with the question number 9. So let's move to the next part. The next question, that question will be question number 10. So here we go. The question number 10 is coming up on your screen. Figure 10.1 is the diagram of a soldering iron. Solder is a mixture of metals used to make a permanent contact between electric wires, and the heating element raises the temperature of the metal tip when solder is placed against the tip. The solder melts over the wires to be joined. When the solder cools, it solidifies and the permanent connection is made. the working temperature of the metal tip is 380 degrees centigrade. The box, so this tip should not melt, but the solder which you touch with it, that should melt. Its temperature is 380 degree. So the question is, the boxes in the figure 10.2 shows two materials and some different melting points. So what we have to do, we have to, on the figure 10.2, draw a line from the metal of the metal from the metal of the metal tip, and a line from the solder to a suitable melting point for each. You see, this metal tip should not melt. This metal tip should not melt at 380 degrees centigrade, but the solder should melt. The solder is a very soft kind of metal wire which touches with it, and it should melt when it touches with this tip. So I have done this. Let me show you my work, and then we will. Okay, so this is question number 10. So here we go. So on your screen, you can see the metal of the metal tip, its melting point should be more than 380 degrees centigrade. So the best answer is 1000 degrees centigrade. You see, when you are doing this process, the metal tip of the solder should not melt. Okay, and the solder metal itself, it's a alloy of different metals, and it should melt at 380 degrees centigrade. So solder's melting point should be 200 degrees centigrade. It could not be 20 degrees centigrade. It could not be 0 degrees centigrade. It is 200 degrees centigrade. So I think that you will be able to understand that how this is done. And let's move to the next part. Okay, so the next part is he says the easy numerical. He says the heating element is rated at 24 volt, 3.3 ampere. The heating element is switched on. The temperature of the metal tip rises from 20 degrees centigrade to 320 degrees centigrade in the first 10 seconds. Calculate the electric energy supplied to the heating element in the first 10 seconds. So very easy electric energy you can find out. IVT. IVT is the formula. So the energy, electric energy, you can find out the energy is IVT. The I value is 3.3 ampere. The V value is 24 volt. And the value of the time is 10 seconds. In this formula, we take the time in seconds. Remember, this thing is very important. The time must be taken in seconds. And the final answer will be 792 joules. If I round it off to the two significant figures, this will be 790 joules. So this is the first part. Let's check what the marking scheme has to say. The marking scheme says, here we go. So you can see question number 10, A part, metal tip should be joined with 1000 degrees centigrade. The solder, it should be joined with the 200 degrees centigrade. Energy is equals to VIT, and the 790 joules will be the final answer. So our numerical is perfect. Okay, so let's move to the next question. He says the metal tip is made of copper and has a mass of 2.3 gram. Specific capacity of the copper is 0.39 joules per gram per degree centigrade. Calculate the thermal energy heat gained by the metal tip in the first 10 seconds. Here we have the specific heat capacity of the copper, and we know the change in the temperature. The temperature changed from 20 to 320 degrees centigrade. So the change in the temperature is 320 minus 20, that's 300 degrees centigrade. We know the mass of the copper. We can find out how much thermal energy is taken by the copper, and heat is equal to mc delta theta. You remember the formula for the change in temperature. Whenever a change in temperature is involved, we can calculate the heat used, that is mc delta theta, where m is the mass, c is the specific heat capacity, and delta theta is the change in the temperature. So I have done this question. Let me show you my work and the numerical which I have solved. And then we can me increase the size. So the heat is equals to mc delta theta. Heat is equals to mc delta theta. 2.3 multiply 0.39 multiply 300. So the answer will be 269.1, which is approximately 270 joules when I write it into two significant figures. So 270 joules will be the answer. So let's check the marking scheme. What the marking scheme has to say. The final answer, yeah, here we go, mc delta theta, and the final answer will be 270 joules. So our numerical is perfect. Okay, so let's move to the next part. The next part is coming on your screen. He says, describe in terms of free electrons the process by which the heat is transferred through the metal tip. You see the portion of the metal which is on the hot end. It absorbs the thermal energy because it's metal. It has free electrons. So the free electrons there, they absorb that energy. Their kinetic energy increases, and because the free electrons, they can flow in the metal. So the free electrons, they absorb the energy. Their kinetic energy increases from hot end. They flow to the cold end, and when they reach the cold end, they collide the atoms there, and they make them vibrate vigorously. So they increase their kinetic energy. So in this way, by the free electron diffusion, the energy is transferred from hot end to the cold end, and this process is called conduction. And this is also called free electron diffusion. So that's a 2-mark question. Let me show you my answer. I've written this answer. Okay. So what will happen? Here we go. Increase the size. Let's increase the size. Okay. So free electrons at the hot end will absorb thermal energy. Their kinetic energy will increase. They will flow towards cold end. Electrons will collide with the molecules of metal on the hot end. Here I should have written cold end. This word should be cold end, and make them vibrate vigorously. This word here, let me show you this word. It should be cold end, and make them vibrate vigorously. So by free electron diffusion, energy is transferred in the metal. So let's check what the marking scheme has to say about this part, and let's check the marking scheme. The marking scheme says electrons move around or electrons diffuse through metal, pass on energy to other parts, hit atoms or other electrons, transfer energy in all directions. So hopefully you understand that how from the hot end to the cold end, the energy is transferred in the metal by the help of electrons. A very, very famous and frequently asked question this is. So let's move to the next part. And the next part coming up on your screen is heat is lost from the metal tip by the convection in the air. Explain how convection occurs in the air. You know, the air which is very adjacent to the hot metal tip, that air will absorb the thermal energy. Its molecules will move away from each other. The air will become hot and less dense. This less dense air will rise upward, and when this will rise upward, what will happen? The less dense and hot air will go up. The cold and the dense air will sink downward. This will set up convection currents in the air, and by the convection currents, then the the heat will be transferred and taken away from the metal tip. So this is how the convection currents are set in the air. Let me show you my written answer, and then we will see the marking scheme, what the marking scheme says. Okay, so on your screen you can see air near the tip absorb energy. Air molecules move away. Air becomes hot and less dense. Less dense air rises upward, and cold and dense air sinks. So convection currents are set up. By convection currents, heat is transferred in the air. So this is the answer which I wrote. Let's check the marking scheme. What the marking scheme uses, what the wording the marking scheme is saying. He says hot air, heated air rises. Hot air less dense than cold air. So you have to build your answer around these 2 points. Okay, So let's move to the next part and see what happens. See, let me. So here we go. Next part. Okay. The temperature of the metal tip is measured with a thermocouple. In the space below, draw a label diagram of a thermocouple. Mark with the letter H the part of the thermocouple that is placed on the metal tip. It's a 2-mark question. And the last part of this question is, state 2 reasons why a thermocouple thermometer is suitable for measuring how the temperature of the metal tip varies during the first 10 seconds. So I have to write 2 advantages why I am using the thermocouple, and I have to, in the first part, it's a 2-mark question, and the first part is also a 2-mark question. Here you have to draw the label diagram of the thermocouple. So I have done this. Let me show you my written answer. So here we go. Okay. So we have here, I have shown a thermocouple. You can see the thermocouple, we have 2 different metals. One is copper, this wire is made of copper, and this wire is made of iron. Here we have the junctions. This is hot junction, this is the cold junction. The cold junction is always in the 0 degrees centigrade. Theoretically, this is the basic principle of the thermocouple, and this hot junction will be put on the hot metal tip. So that's why I have written H here. Here we have a voltmeter, and this is the basic diagram of a thermocouple. Why we are using a thermocouple? Because the thermocouple is able to measure rapidly changing temperatures. This is one reason. The other reason is that the thermocouple range of temperature which it can measure is very large. It can measure very high temperatures. Another good reason is the thermocouple's output is electric output, which can be fed through a data logger into a computer, and the computer will keep the record of the temperature against the time, and which will be a very good thing. It will make your life easier. So this is question number 10, and let me check the marking scheme. What the marking scheme has to say. So let's check the marking scheme. What the marking scheme says. Okay, so question number 10, 2 different metals, a complete circle with meter in series, and 1 junction labeled H on the hot tip. Okay, so question number 10D, the second part, can measure the rapid temperature changes, can measure high temperatures, is small in size, has a small heat capacity, and can give electrical signal, be read by the computer. So you only have to write 2 advantages why we are using a thermocouple, why using a thermocouple is a better option. So this was the question number 10, my dear students. Let's move to the next part. The next question is question number 11. Today we are doing May-June 2019 2-2 paper. This paper is zone 2 paper, and it's a theory paper. We are doing in this session, we are only attempting the section B of this paper. So the next question on your screen. Stars are formed inside a cloud of gas and dust in space. When a star forms, the cloud first becomes smaller as it collapses. State what causes the gas cloud to collapse. You see, that cloud has a very strong gravity. It has a gravitational attraction. So due to that gravitational attraction, the cloud will collapse. So let me read my answer and then we will move on. Okay, so here we go. The gas cloud collapses due to the very strong gravitational attraction. It has a very strong gravity. Due to that, it collapses. So, okay, so the next question coming up on your screen, we will check the marking scheme later. Let's first do 2 questions. Eventually, nuclear fusion occurs in the star. State 2 condition required for the nuclear fusion to occur in the star. For the fusion, nuclear fusion because the positive nucleus has to come close to each other. So the two conditions are that the temperature should be very high and the pressure should be very high. These are the two conditions which are required for the fusion to take place. Otherwise, you see both the nucleus, they will be positive. It's just not possible for them to come close to each other. So when the pressure is very high and the temperature is very high, then they come close to each other and fuse into each other. Let me show you my answer. I have written this answer, the very high pressure and very high temperature. These are the two conditions which are must for the fusion to take place. Okay, so now let's move to the next part. The next part is when a large star explodes, nuclei of heavy elements are formed. One such nucleus is uranium-235. State the name and the number of each type of particles found in one nucleus of uranium-92-235. You see, it has protons and there will be 92 protons, and it will have neutrons in the nucleus, and the number of neutrons will be 235 minus 92. Let me show you. I have written this answer, and then we will. Okay, so protons are 92 and neutrons are 235 minus 92, so 143. So there will be 143 neutrons in the nucleus. Okay, so the next part is state one feature that is the same for the nuclei of all the isotopes of the uranium. You see the isotopes of the uranium, they will all have the same number of protons in their nucleus. I means they all will have 92 protons in their nucleus. So let me show you my written answer, and then we will check the marking scheme. Okay, so all isotopes of uranium have 92 protons in their nucleus. So this is my answer. Okay, so let's first check the marking scheme, and then we will do the further questions. Question number 11, A, first part, gravity or gravitational attraction. Question number 11, A, second part, high pressure, very high temperature, high particle density. And question 11, B, first part, proton number 92, neutron number 143. Our answer is right. So same number of protons. Okay, so we are done with the question number 11B, second part. So now let's move to the next part. And the next part is, second part. State one feature that is we are done with this. The third part is a nucleus of uranium-92-235 is in a nuclear reactor can undergo nuclear fission. Describe the process of nuclear fission in a nuclear reactor. So what we do in the nuclear reactor, we take a uranium atom. This is theory, okay? So we take a uranium atom and we bombard a neutron on it. So when a neutron hits the nucleus of a uranium-92-235, the nucleus is broken and it splits into two smaller nuclei, barium and krypton, and three more neutrons are given out. And during this process, enormous amount of energy is also given out. Let me show you my work, and this is how the okay, so there we go. So you see, a neutron is bombarded on the uranium-92-235. Nucleus of the uranium-92-235 breaks into smaller nuclei of the barium-56-139 and the krypton-36-95. Lot of energy and three neutrons are also produced. This is the byproduct of that reaction. Lot of energy and three more neutrons. And those three neutrons, they can further bombard other three uranium nucleus, and this process goes on. So let me check the marking scheme, what the marking scheme says about this. So here we have neutron is absorbed by the uranium nucleus. Nucleus splits, so smaller nuclei formed or emits more neutrons. So this is question number 11B, second part. So let's move to the next question. He says, state one difference between nuclear fusion and nuclear fission. in the nuclear fusion, you see smaller nuclei, they fuse into each other and they make a larger nucleus. Whereas in the nuclear fission, a larger nucleus is broken and smaller nuclei are formed. So this is the main difference between the nuclear fission and nuclear fusion. So let me show you my answer, and here we go. So here we have, in nuclear fusion, smaller nuclei join to make a larger nucleus. In fission, a larger nucleus breaks down into smaller nuclei. So that's the okay. So let's move to the next part. But let's check the marking scheme first. You see question number 11B, fourth part. Fusion coming together and fission splitting up, or fission involves large particles, nuclei, and fusion small nuclei. In fusion, nuclear waste products are less radioactive, dangerous, or no few neutrons produced in the fusion. Okay, so these, I think the answer we wrote is the best answer. So let's move to the next part. He says the nucleus of the uranium-92-235 is not stable. It decays by the emission of an alpha particle into a nucleus of thorium. Complete the nuclear equation that represents this decay. So here an alpha particle is given out. Alpha particle's proton number is 2, its mass number is 4. The thorium, whenever an alpha particle is given out, the proton number of the daughter nucleus should be 2 less than as compared to the parent nucleus, and its nucleon number or mass number should be 4 less than the parent nucleus. So very easy. Let me show you my work, and I have written this equation. So you can see this equation is coming up on your screen. So here you have to write 2 because the alpha particle is nucleon number is 4. The thorium, which is a daughter nucleus here in this equation, so its proton number will be 2 less than the proton number of the parent nucleus, that should be 90, and its mass number should be 4 less than the mass number of the parent nucleus, so it should be 231. So hopefully you have understood. Let me show you the marking scheme, and then 90 proton number of thorium and 231 and 4 nucleon number. So our answer is right. Well, question number 11B, fifth part, our answer is perfect. Okay, so let's move to the next question. Okay, he says the Geiger and Martin carried out an experiment to investigate the scattering of alpha particles. Figure 11.1 shows a diagram of the apparatus that they used. Okay, so here we have the radioactive source. Here we have a beam of alpha particles coming out. Here we have a very thin gold foil. We have vacuum, and there is fluorescent screen. So wherever the alpha particles, after passing through the gold foil, will strike, there the screen will glow. Okay, so when an alpha particle strikes the fluorescent screen, a flash of light is emitted on the figure 11.1 marked with the letter P, where most flashes occur on the screen. You see, and during this experiment, an interesting thing they observed is when they pass the alpha particles through the gold foil, most of the alpha particles go straight undeflected, and it appears that it seems to be like that there's nothing in their path. And so the most of the alpha particles will go straight and strike here at this point. Let me call it P. Okay, so hopefully you have understood. Okay, so the next question coming up on your screen, he says, describe what is seen on the other parts of the screen. On the other parts of the screen, because most of the alpha particles are going straight, on the other parts of the screen, there will be some glows, but very few glows, because very few alpha particles are deflected on the, so there will be very few glows on the other parts of the screen. Most of the glow will be right in the center of the screen. So because most of the alpha particles went straight through the atom. So the next part is, which is the last part, it says state two conclusions about atoms of gold that resulted from this experiment. By this experiment, they concluded that most of the space in an atom is empty and there is a very small nucleus inside the atom. All the mass is in that and in that nucleus, and all the positive charge is in that nucleus. These are the two conclusions which they drawn from their experiment. So let me show you what I have written, my written answer. So as you move away from the center of the screen, fewer flashes will be seen because very few alpha particles will be deflected, or most of the alpha particles are going straight. Most of the atoms is empty space. Most of the mass of an atom is in the nucleus, which is in the center of atom and is very small as compared to the atom. So these are the two conclusions which they have drawn from their experiment. Geiger and Martin, they concluded these things. Okay, so here we have the mark scheme. P mark where beam of alpha particle hits the screen. Fewer flashes as one moves from center, or very few, only few flashes on same side as source on left. Any two bullet points from nucleus is small, or atom mostly empty space. Most mass of atom in the nucleus or mass is concentrated in small pointer region, or nucleus is dense, or nucleus is massive. Charge concentrated in small region, or positive charge found in the nucleus, or nucleus has all the positive charge of the atom. So my dear students, today we have done, today we have done, let me set this first. Today we have completed the May-June 2019 Physics 5054 2-2 paper. And today in this video, we have only done the section B of this paper. I hope that this video is useful to you. This will be helping you in solving the past papers. And if this video is helpful to you, kindly subscribe to my YouTube channel. Also hit the press the bell icon so that whenever I make a video, you get the notification in your YouTube. And also suggest these videos to your friends, because if they are helping you, they will also help them. So that everybody who watch these videos can benefit from them. So I think that is enough for today. So thank you very much, everybody. Have a good day, and God bless you all.